Hi, guys, and welcome back to week 3. Let's get started. So, this week we're going to be talking about crossover events. These occur during meiosis and is when chromosomes exchange bits and pieces to form new recombined chromosomes. These chromosomes then divide further into chromatids. So, we'll start with 2 chromosomes and end with 4 chromatids. A synapse is the event that must occur to break the combined chromosomes back into their own individual pieces after the crossover event. And sometimes during these crossover events, some pieces can accidentally be duplicated, deleted, inverted, etc. These are called chromosomal aberrations and make the gamete produced not viable. Non-viable means not able to live, grow, or reproduce. Therefore, if a produced gamete has a chromosomal aberration, we can assume that it will be non-viable and not survive. So we're going to try to understand this by looking at an example of 2 chromosomes. We can see them at the top here. This period here represents the centromere, which signifies or marks the center of our chromosomes. And our crossover event is going to be between J and K. So I drew a picture. Let's zoom in to look closer. Here we have our 2 chromatids for chromosome 1 and our 2 chromatids for chromosome 2. And our X is where our crossover event is going to occur. So now we have our 4 gametes produced. We can tell that 1 and 3 are viable gametes, but 2 and 4, if we look closely, we can see that there's duplication in both of these. Duplication is one of our chromosomal aberrations that will make our gamete non-viable. In our next example, we just changed our second chromosome a little bit, but we're going to cross them at the same location. So let's zoom in on this picture. So here we have our 2 chromatids for chromosome 1 and our 2 chromatids for chromosome 2 and our crossover event. So here we have 4 gametes produced again. Our first and our third are both viable, but if you look at our second, we can see that there's 2 centromeres. 2 centromeres is called a dicentric gamete and will result in a non-viable gamete. If we look at number 4, we can see that there's no centromere. This is called acentric and will also result in a non-viable gamete. So in comparing these 2 instances, will there really be a difference in expected fitness between the 2 of them? The answer to this is no, because both people have 50% viability in their gametes. Therefore, only half of their offspring will live for both situations, and they're about equal. Here are my references, and thanks for listening. See you guys next week.